Alright, this is homework 2. Start with 5-66. Determine whether 447 is a term of each sequence below. If so, which term is it? So let's look at A. Alright, so the question is T of n equal to 477? And the way you think about these is you take this equation, think about it like a function machine. What number do you have to input for the output to be 477? And remember, sequences only input whole numbers. So what do? You take the equation they give you and you set it equal to 477 and solve for n. In this case, add 3 to each side. 5n equals 480. And then divide both sides by 5. $96. Okay, so n is our term number, and we can say that term 96 is 477. So term number 96 is 477. Alright, let's do one of these harder ones. How about E? It's the same idea. Imagine you have a function machine, and the equation is your function. Alright? And the question is, can we have T of n, can we have a term in the list that's 477? What number would we have to input for that to happen? So just like before, you take the function equation and you set it equal to the output. Alright, this one requires some rewriting, so distribute that -7. -7 times n is -7n, and -7 times -1 is positive. Negative times negative makes positive. Okay, don't forget to combine like terms. -8 and 7 make -1. Alright, adding 1 to each side. Now let's solve for n. So these 1's go away, and we get -7n equals 478. Alright, dividing both sides by -7. Don't forget to divide by the negative. Let's see what we get. So that is 478 divided by -7. So n is equal to -68.28. So what that means is if we input -68.28, we can have our desired output. But that's bad. As a reminder, sequences only take whole numbers as inputs. Alright, so our answer here is no. There can't be a -68.28 term. There can't be a -68.28 term. You can only have the first term, second term, third term, fourth term, but you can't input a decimal number. (5-68) Determine the common difference, the sequence generator, for each arithmetic sequence listed below. Then write an equation, the nth term in each sequence, keeping in mind that the first term of each sequence is T1. So let's start with A. This is T1. And it goes 4, 7, 10, 13. So it looks like it's growing by addition by 3. Common difference, M, equals 3. Common difference is kind of like slope or growth, so that's why it has the letter M. Alright, so to write the equation, T of n equals 3n plus, and then we have to add our starting value right here. So to get our starting value, we find the 0 term. So that's the imaginary number that would be at the beginning of the list. And in this case, that's 1. 3n plus 1. Let's look at D. So the first term in the list, that's T1. So again, we need to find our 0 term, and we need to find our common difference. So this one's a little bit harder to spot. Let me subtract 9.5 minus 7. It's 5 to 2.5. So it's adding by 2.5, and then if we check 9.5 plus 2.5, we get 12. So our common difference M equals 2.5. Alright, so the equation T of n equals 2.5n plus, we need our 0 term, our starting value. So what we do is we take 7, and then we go back. And we go back by doing the opposite of adding 2.5. Okay, so let's take 7 and subtract 2.5, and we get 4.5. That's the 0 term. And that's the number that goes in our equation. (5-69). Great Amusement Parks has been raising ticket prices every year. You can see in the table. How are they growing? So it looks like from year 0 to year 1, it adds 5. Between those 2 years, you can find how much it adds. Let's see, it subtracts 60.5 minus 55. So it adds 5.5. Okay, and then let's subtract the difference between the next 2 years as 66.55 minus 60.50. So it adds $6.05 or 6.05. But there doesn't seem to be a pattern there. So it doesn't grow by addition, not by addition. Let's try multiplication. Okay, so instead of subtracting, let's divide. 55 divided by 50. And that is 1.1. 1.1. So we're gonna take that. Let's consider 50 times 1.1, which gives us, 55. All right. So I divided those two numbers to get 1.1, and let's try multiplying 55 times 1.1. And that's 60.5, or 60.50. Okay, so that matches. And let's try multiplying by 1.1 again. 60.5 times 1.1 is 66.55. So we found our pattern. Multiplication by 1.1. Alright, so I'll let you answer the next question. Just keep following the pattern of multiplication to get year 6. Avery and Colin were trying to challenge each other with equations for sequences Avery was looking at an explicit equation that Colin wrote. Write the first 4 terms for the sequence. So to get the first term, what you do is you plug in 1, replace n with 1. Alright, so that's 4.5 times 1 minus 8. That's 4.5 minus 8. Negative 3.5. Okay, so that's the first number in our list. To get the second number, plug in 2. Alright, so you replace n with 2. So 4.5 times 2 is 9, and then we still have to take away 8. So this is 9 minus 8, which is just 1. Alright, and then you can kind of proceed this in this way. I'm going to go a little bit faster on these last couple ones. 4.5 times 3, that's going to be 13.5 minus 8. That's 5.5. So the big idea here is to get each term, you just plug in whatever term you're looking for. Like for example, if you want term 4, you just plug in the number 4. Okay, so that's going to be 18 minus 8, which is 10. Okay, what would Avery do to write the 15th term of this sequence? What number do you think you'd have to plug in? I'll let you answer that. 578. Write both an explicit equation and a recursive equation. So I think I'll let you write the explicit. I'll go for the recursive. So looking at my list of numbers, it would appear that this list grows by adding 3. So to go to the next term, what you do is you take what you have now, you take the now term, and then you add 3. So if I wanted to find this next term, I would take what I have now, 17, and add 3. So how do we write that mathematically? T of n plus 1, that's the next term, is equal to the now term, which is just t of n, and then you add 3 to that. Don't forget, for the recursive equation, you need to say where it starts, t of 1, the first term, which is 5. And that's the recursive. Okay, and if you don't know what explicit is, that's the thing, check your notes, mn plus b. T of n equals mn plus b. 579. I'll let you do this one. I'll do part B. Don't write 16x squared plus 25. That's wrong. First thing you do is rewrite it. When you have something raised to the power 2, that means you have to repeat it 2 times, repeated multiplication. Alright, and I'll do the FOIL method. These are all the multiplications I need to do. Let's start with 4x times 4x. 4 times 4 is 16, and x times x is x to the power 2. Okay, and then I do 4x times 5, which is 20x. Then I do 5 times 4x, which is also 20x. And lastly, 5 times 5, which is 25. Don't forget to combine like terms. 20x plus 20x is 40x. Alright, Tuesday's homework, 5-80. Lana received a stamp collection from her grandfather. The collection is in a leather book and currently has 120 stamps. Lana joined a stamp club which sends her 12 new stamps each month. The stamp book holds a maximum of 500 stamps. So if she gets let's see, 12 new stamps each month. Looking at this table here, it looks like it's just keeping track of the months for us. And every month adds 12 stamps. It's the collection. So this first part should be pretty easy, right? You just add 12 every month. 132 plus 12 more stamps, so she'll have 144 in the next month. And then over here, in the next month, she'll have 156. After that, 168. 12 more the next month, that brings your total up to 180. That's part A. Part B, I'm actually going to do part C and come back to part B. Write an equation using function notation to represent the total number of stamps that Lana has in her collection after n months. Let the total be represented by T of n. Well, the common difference is something we already found. M equals 12. And the 0th term is 120. Okay, so you just write the equation as T of n equals 12n plus the starting value, or the 0th term in this case. Alright, so how many stamps will Lona have 1 year from now? I could keep going and adding 12, or I could plug 12 into this equation. And that is the solution I'm going to do. 12 times 12 is 144. And I plugged in 12 because we're talking about months. We've got 12 months in a year. So if you plug in 12 to this equation, it'll calculate how many stamps are available in 1 year. 264. Alright. 5-86. Identify the following sequences as arithmetic, geometric, or neither. And then for arithmetic and geometric, identify the growth pattern. So you can see clearly this one is really growing fast, and so I'm going to take a guess that this is geometric. This is probably growing by multiplication. So let me compute a guess. I could take the second number, 144, and divide it by the first number, and that's 12. Yes. So let's try multiplying by 12 and see if it works out. Okay, so I start with 12, and then I multiply by 12, and I get 144. Good. And then I take 144, and I multiply by 12, and I get 1,728. Correct. So this is geometric. And the growth pattern is multiplication by 12. Alright, let's look at C. Doesn't grow by addition because 0 plus 4 is 4, and then 4 plus 12 is 16. So it can't be arithmetic. I do know 4 times 4 is 16. I know that. So let's see what, if we follow the pattern, what is 16 times 4? 64, and in our sequence we have 36, so this is not geometric. It doesn't grow by multiplying the same number, like this one did. This one's going to be neither. 5-87. Write the first 5 terms of each recursively defined sequence. So let's start with A. Let's try plugging in n equals 1 to this equation. I get t of 1 plus 1 equals negative 2 times t of 1. So t of 1 plus 1, that's just t of 2, and that's equal to negative 2 times t of 1 is just negative 3. So t of 2 is equal to 6. So we have our first term, our second term. Now let's plug in n equals 2 into this equation. So if I put a 2 in right there, I would have t of 3, 2 plus 1 is 3, and that's equal to negative 2 times t of 2. So t of 3 equals negative 2 times 6, which is negative 12. So the pattern it looks like is to get the next term is equal to negative 2 times what you have now, right? Negative 3 times negative 2 is 6. 6 times negative 2 is negative 12. So let me erase this and just start writing out the terms of my sequence. Negative 3, 6, negative 12, and now that I've identified the growth pattern as negative 2 times negative 2 times negative 2 times negative 2, let me go ahead and finish this. Right, so I'm at negative 12 right now, and if I multiply by negative 2, that's 24. Okay, and then if I'm at 24, to go to the next term, I multiply by negative 2 again, and I get negative 48. So the recursive equation is basically instructions. To get the next term, you do negative 2 times what you have right now. Let's look at C. C is a little more difficult. So same idea, let's plug in n equals 1. So if I put 1 in right there, that's t of 1 plus 1. Or in other words, t of 2 is equal to t of 1 raised to the power negative 1. So t of 1 is our first term. So if I replace that with 2, what do I get? I get t of 2 equals 2 to the power negative 1. Now if you remember negative exponents, you flip the 2, have it cross the line, and then change the sign of the exponent. 2 raised to the power 1. But recall that 2 raised to the power 1 is just 2. So this is 1 over 2. Okay, to get our second term, if we plug in n equals 2, I put a 2 right here, and this becomes t of 3 equals t of 2 raised to the power negative 1. So the third term, t of 3, is just the second term raised to the power negative 1. Okay, so what does this do? This causes it to flip back to become 2 again. And if we put in n equals 3, if I put a 3 right here, 3 plus 1 is 4. So that's t of 4, the fourth term, is equal to the third term raised to the power negative 1. So this is the pattern. To get to the next term, you flip the previous term. Okay, and I already know how to do that. This is just 1/2. So writing out the first few numbers of my sequence, it's 2, then 1/2, then 2, then 1/2, then 2, and I could keep going, but it just says first 5 terms. 590. Simplify. Okay, part A. So when I multiply these things together, this is what I'm doing. I'm going to be thinking of the coefficients, 2 times 4, and then the m terms, m to the power 3 times m to the power 2. 2 times 4 is 8, and when I multiply two m's together, the exponents add. Eight m to the power 5. So you multiply the numbers in front to get 8, and then when you multiply the m's together, you add the exponents. For part B, let's do C. So for C, it's helpful to think of these as separate fractions. Alright, negative 4 over 6 times all this chunk. Well, 4 over 6, I know these are both even numbers. So let me divide the top and bottom by 2 to simplify the fraction. 4 divided by 2, that's negative 2 over 3 times. Well, I have 2 y's on the top. I have 7 y's on the bottom. So 2 of the y's cancels. And I have nothing left on the top but a 1, but I still have y to the power 5 on the bottom, right? So the 2 y's on the top vanish with 2 y's on the bottom, leaving 5 y's left on the bottom of the fraction. And then you multiply everything back together. 2 times 1 is negative 2, because that was negative, and then 3y to the power 5, answer. Okay, 591. This problem is a checkpoint for writing the equation of a line. Use the given information to write the equation of each line. As a slope of 2 passes through this point. So recall that this is the equation of a line. A slope of 2, that's m equals 2. And then if we have a point, we have an x-coordinate and a y-coordinate. So let's take y and replace it with 17. 17 equals m, which is 2, times x, which is 10, plus b. So you plug in 3, leave b. 2 times 10 is 20. 17 minus 20 is negative 3. So b is negative 3. M is 2. B is negative 3. Answer y equals 2, x minus 3. Let's do one more. Let's do the graph. Okay, so on a graph, this point right here, this is your starting value. That's your b value, which in this case is 9. And then we also need the slope. And to get the slope, it's good to draw a slope triangle. So I'm going to pick a corner point. Any one of these would work. Let's try this one. Okay, so there's a slope triangle. And this is going to be our run, and this is going to be our rise. So let's see here. From here to here along the x-axis is actually just 2 units. And then along the y-axis, bottom to top, it goes from 9. 9 goes all the way up to 14. 9 to 14. So it rises 5, 2, 3, 4, 5, and a run of 2. So m, which is equal to rise over run, is just 5/2. B is 9. Y equals 5 over 2x plus 9. Convert each percent increase or decrease into a multiplier. Alright, let's not forget, we need to start at 100%. So for a 3% increase, start at 100%. increase means add. 100 plus 3 is 103%. Now if we take it back to a decimal to get our multiplier, 1.03. How about this one? Actually, let's do C. So for C, don't forget to start at 100. Decrease means subtract. 100 minus 13%. And 100 minus 13. Let's see, this is 9, 10. 10 minus 3 is 7. 9 minus 1 is 8. So this is going to be 87%. Right? And then move the decimal over. 0.87. Don't forget to start at 100. That's the common mistake here. Avoid that mistake. Wednesday. Identify each sequence as arithmetic, geometric, or neither. And if it's arithmetic or geometric, identify the sequence generator. Let's check out part C, or number 3 actually. Number 3 it says. So we're at 16, then 8, then 4, then 2, then 1. This looks like a half. You can see that it's dividing by 2. But we don't want to say divide, we want to say times. So 16 times what is equal to 8? Well, to figure that out, let's divide. 8 divided by 16, 0.5. Makes sense, right? So 0.5 times 16, that's going to be 8. 8 times 0.5 is 4. 4 times 0.5 is 2. So it's halving each time, or multiplying by 0.5, sorry. And that makes it a geometric. Geometric sequences, they multiply to go to the next term. Okay, so if you notice, this is kind of similar. 16, 9, 4, 1, 0, 1, 4. But it starts decreasing and increasing. This is part of the neither family. And you don't have to do a sequence generator because it's neither. Try A, or I'm sorry, try number 1. This is 5-104. Write the equations of the line parallel to the given one, passing through this point. Parallel means same slope. Alright, so we need our slope, which will be the same. And we'll pick a point. They only give us 1 point. So that'll be our x and y coordinate. So here's what we're going to do. We're going to take the equation of a line, y equals mx plus b, and we're going to plug in x, we're going to plug in y, we're going to plug in m. Plug in 3, leave b, b. So this is -1 equals -1/3 times 9 plus b. Okay, this is -1 equals, now we have a fraction times a whole number. So what you do here is you put the whole number over 1, and you multiply straight across. 1 times 9 is -9 over 3 times 1 is 3. Okay, so this is -1 equals negative divided by positive. That's -3 plus b. Add 3 to each side, and -1 plus 3 is 2. Alright, so my equation is y equals -1/3 x plus 2. Alright, so for part B, here's how you can think about it. This is called looking inside. We can use the looking inside method. And we're going to ask ourselves, what number plus 4 equals 9? And that's 5, right? So the square root of x has to equal 5. But what number do you square root to get 5? 25 is my guess. Yep, square root of 25 is 5. Right? Because 5 times 5 equals 25. Yes. So, square root of 25 plus 4, that's just 5 plus 4, that's just 9. And that's what we wanted. Answer, x had to be 25. If x is 25, then this works out. So you can kind of solve this one the same way. 8 minus what number is 3? 8 minus 5, right? So 2x plus 1 has to equal 5. 5109. Here's our 3 sequences to consider as you complete the parts below. Alright, let's assume that each sequence above is arithmetic with t of 1 as the first term. So this is t of 1. Determine the next 4 terms of the sequence. For each sequence, write an explanation of what you did to get the next term, and write an equation for t of n. So this is actually quite a bit of work. I think what I'll do is I'll just do one sequence for A, B. So you can see this one, if this is arithmetic, that means it grows by addition. And it would have to be adding by 4, this sequence. 2 plus 4 is 6. Okay, so let's assume that it follows the same pattern. To get the next terms, 10. Determine the next 4 terms. 14, 18, 22. And I got those just by following the pattern. Add 4, add 4, add 4. Okay, so explanation, add 4, equation, t of n equals 4n plus, we need our 0 term. So if we go back to before the list even started, we have to kind of go back in time here, so let's subtract 4. 2 minus 4 is negative 2, and that's our 0 term. So our equation is going to be okay, part B. Now let's imagine that each sequence is geometric. That means it grows by multiplying. Determine the next 4 terms for each sequence if they're geometric, and then same situation. Explain and write an equation. Okay, if these are multiplying, the way you figure out what it's multiplying by is you take the second number and you divide it by the first number. That's 3. 2 times 3 is 6. Of course, 2 times 3 is 6. So let's keep following the pattern to move forward. Let's multiply by 3. 6 times 3 is 18. 18 times 3 is 54. And keep multiplying by 3. 54 times 3 is 162. And lastly, 162 times 3 is 486. So we have the next 1, 2, 3, 4. 4 numbers. Okay, to write the equation, that's t of n equals, don't forget this is the one that's a little different. It's a times b raised to the power n. So basically we need our 0 term. Okay, so to go forward, we times by 3. To go backward to the 0 term, we divide by 3. And what is 2 divided by 3? Well, that's just 2 divided by 3, or 2/3. So in this one, the 0 term comes first, and then we multiply by our multiplier, also known as common ratio. Alright, so you can do sequence 2 for this one and that one, sequence 3 for this one and that one. Let's see what part B says. Just a reminder, for number A, or part A I should say, you use the equation mn plus b, and then for part B, you use the equation a times b raised to the power n. Okay, part C, create a totally different type of sequence for each pair of values shown above, based on your own equation. Write your equation clearly, using words or algebra, so that someone else will be able to determine the next 3 terms that you want. So let's look at this one. Let's say my equation is I'm going to square the term and then add 2. So check this out. 2 comma 6. 2 squared is equal to 4. 4 plus 2 is 6. Alright, and then I'll square 6, add 2, and that's 38. Okay, and then I'll square 38, add 2, 46, 1446. Square that, add 2. This is a big one, 2,090,092. Okay, this one just says write the next 3 terms that you want, and there's 1, 2, 3. Couple more. This is 5-110. Alright, so the way to solve this equation is by rewriting So let's rewrite using FOIL. X times x is x to the power 2. FYI, you can also draw the box on this one. Either way is just fine. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. Combine like terms. X squared plus 5x plus 6 equals x squared minus 10. So I've got an x squared on each side, I mean. If I subtract x squared from each side, they cancel, leaving 5x plus 6 equals negative 10. Solve for x, take away 6 on each side, 5x equals negative 16, and then you divide by 5. There's x. Let's look at b. For b, this is an equation with fractions, so let me look at the denominators, and let me find the LCD of 2, 3, and 6. So the LCD of 2, 3, and 6. Well, 2, 4, 6, 8, those are some multiples of 2. 3, 6, 9, 12, those are some multiples of 3. And if you notice, the least or smallest number in those set of numbers is just 6. The LCD of 2 and 3 is 6. So why did I go through that trouble? Well, 6 is the magic number to multiply this equation by, so that the fractions will go away. So let's multiply the 6 times everything. Let's start over here. 6 times a half. That, remember, I multiplied the top of the fraction. That's 6 over 2x plus 6 times 1 is 6, 6 over 3x minus 6 times 7 is 42 equals 6 times 5, it's 30 over 6x. And let's simplify. 6 over 2 is 3. 3x plus 6 over 3, that's 2. This is 5x. We do need to combine like terms. 3x plus 2x, that's 5x minus 42 equals 5x. Alright, and then let's take away 5x on each side. And what we notice here is negative 42 equals 0. X is gone. Alright, and negative 42 is not equal 0. So what we have left is false. So what is our answer? There's no solution for x. X is gone, the leftover is false. That's how you know. Alright, so that one was quite a bit of work. Let's finish this one off with something that's maybe a little easier. I hope. We'll see. Alright, so if f of x equals this fraction thing, calculate each of the following values. This is called a rational expression. So let's start with part A. Plug in negative 3 for x. So that's 1 over negative 3 plus 2, which is 1 over negative 1. Please simplify. 1 divided by 1 is 1. Positive divided by negative is negative. Now let's try D. If f of x equals 5, how do we approach this? We replace f of x, the left-hand side, with 5. So don't plug in x this time. You take the rational expression, the fraction, and you set it equal to 5. Okay, so this is a little tricky. The denominator is x plus 2. So you multiply both sides by x plus 2. So that's 5 times x plus 2 equals 1 times x plus 2 is just x plus 2. Alright, now if I multiply 5 times x plus 2, I have to put it in parentheses and distribute the 5. This is going to be 5x plus 10. 5x plus 10, good. And then over here, if you have something divided by itself, even if it's really ugly, right? Because this is just a bunch of junk divided by the same bunch of junk. Anything divided by itself is 1. And from there it gets a lot simpler. Just take away 10 from each side. 5x equals negative 9. And then you divide both sides by 5. X equals negative 9 over 5. Which you can write as negative 1.8.